Okay, enough jibber jabber. Let's see how to code this. Let's write a function, and we know how to do that by writing def bubble sort. It will take an array, and now what we want to do is for I and range length of the array, and I will print here pass I plus 1. So this is what I was talking about. So this for loop is the outermost for loop, and you can consider this as a pass. And for bubble sort we have to write two for loops. So for loop inside a for loop. So j in range of 0 to it will be 0 to length of array minus I. Let's just take length of array here. We will optimize it later and see how we can do that. Okay, so now we know that we have to compare adjacent elements, right? So this j for loop, the first for loop is just to create the passes, and the second for loop is so that we can access the array's element. Now so we know that we want to compare adjacent elements. So let's take the first element equal to array and the second element j plus 1. So when the j is 0, it will give us the first element, and j plus 1 will give us the adjacent element, as you can see. So 0 and 0 plus 1 is 1, and when j is 1, it will give us 1 and 2. So that's what we did here, right? We compared 1 and 2, then we compared 2 and 3. So I think you got it now, what this j and j plus 1 is doing. So we want to check if array j is greater than array j plus 1. Okay, we have to write if here. If this is the case, then we want to swap them, and in Python there is a easy way to swap them using the line which was just showed by the IntelliSense, but let's do it how we should actually do it. So to swap the elements you have to use a temporary variable, because if you write let's say you take the 32 and you write it at the index 1, then the second value is lost, right? The array would become 32. So you need to store the 64 in some temporary variable. So let's create that. So temporary variable equal to array j, and then what we can do is we can array j equal to j plus 1 and array j plus 1 equal to temp. So what this is actually doing is storing the value of j, which is 32, into this temporary variable. So temporary would be now 32, and then we are now replacing j to be 64. Okay, this we don't want it to swap, so let's look at this 64 and 1. But let's say we wanted to swap it, so 32 and 64. So temp would store 32. Now we will make this 32 64. So now this is the current state of array, and since we have already stored the value 32 into the temporary variable, we can come here and at the j plus 1 we can assign the temporary value, so 32. So this would do the swapping for us. So that's how the temporary variable helps us in doing that. Let me just undo these things. Okay, so that's a swap, and yeah, that's the whole algorithm. We can modify it to make it more optimized, but let's just run it first and see how it works. If name equal to main array, let's just take this 3264, then 159. Okay, then yeah, that's it. Let's hope it works. And no, okay, index out of range. So I was expecting this, because when we come to the last element, it will try to create an index of 4 plus 1, which is 5, and 5 is not present, so we have to do a -1 here. Okay, now you can see that the array is sorted in the console. You should be able to see, but if we look at the Muro board, we notice that the array was already sorted on the second pass, but we have ran unnecessary passes. So what you can do is create a boolean. So you can create swapped equal to false, and in this we can make it true, and we have to come out of this inner for loop and write in the first for loop, which is our loop which we use to do the passes, and there if nothing is swapped, we will just break the loop. So when we look at the third pass, you can see that we didn't do any swapping here, so that means the array is already sorted, and then you can just stop the process. Okay, so let's see now. What is the issue? We can debug it. So in the first iteration it was false, then it was set to true, then I think I have to make it false again here. Swapped equal to false. Yeah, so now you can see it only ran till passes 3, and the reason we have to add swapped here is because once this value becomes true, it stayed true, and for every iteration during the initial phase we wanted the value to be false, right? So it completed the first pass, so the value became true for swapped. Then it completed the second pass, so we again have to initialize the value, not initialize change. Yeah, that was the bubble sort, easy peasy. Next we will look at some more algorithms. Yeah, that's it. Peace.